Cool. We'll get started. So thank you guys for joining us. I have a confession to start with. The title here is a little misleading. We are going to talk about open source SQL on Hadoop, but we're actually going to talk about one tool in particular that we're very excited about. For those of you who might have read a press release on Monday from Teradata, you probably know where we're going to go with this. If you haven't, though, and I'm going to assume you haven't for a moment, because there's lots of press releases that come out at Hadoop Summit, let me just build the anticipation for a moment and tell you first about myself. So I am Justin Borgman. I'm the Vice President General Manager of what we call the Teradata Center for Hadoop. But I'm actually pretty new to Teradata. So I came to Teradata through the acquisition of a company called Hadapt. Raise your hand if you guys have heard of Hadapt. All right, that's pretty good brand awareness. So anyways, the brief history on Hadapt is we were actually a SQL on Hadoop company. We spun out of research in the Yale Computer Science Department by my two co-founders, Daniel Abadi, who's a professor there, and his PhD student, Camille, who's both of whom still work with us now at Teradata. And we spun that out, built a business around that, and then ultimately were acquired by Teradata last summer. And after that acquisition, actually, we were thinking about, okay, what should we do with Hadapt? Do we sell it the way that we were selling Hadapt before, which was as a proprietary product? What should we do? And I think one of the lessons we learned along the way through the Hadapt experience was that the Hadoop market in general loves open source software, and that's really what people want. So we thought about, should we open source Hadapt? We were very proud of the work we had done there. We had built probably the best SQL on Hadoop engine that ran natively in Hadoop. It was able to run TPCH without any modifications. It had a pretty advanced optimizer. But we thought if we open source Hadapt, it'll be just another SQL on Hadoop engine and probably won't have the impact that we want. So with that in mind, we then thought, well, is there a existing SQL on Hadoop solution out there that really stands up to the test, that meets the bar for what we think a enterprise-grade SQL on Hadoop solution should be, and maybe we can contribute all of the lessons and IP and team and everything that we've developed at Hadapt and really get behind another project. And so we started looking at a number of the SQL on Hadoop solutions out there, all the ones that I'm sure you're familiar with. And really, only one of them got us excited. And that's what we're going to talk about today. And that is Presto. So we are bringing Presto to the enterprise. Now, if you don't know what Presto is, we'll tell you a lot more about it in a moment. But first, let me tell you what Teradata is actually announcing here. So first of all, we are making 100% open source contributions to Presto, which is pretty big investment on Teradata's part, considering everything that we had done at Hadapt. And we're going to contribute that 100% open source. We're also committing to a multi-year roadmap of improvements to Presto. And we're offering the first ever commercial support offering for Presto. So if you want to deploy Presto in production in your data center, we will offer support for that in a very standard kind of open source support model. So first of all, what is Presto at a high level? Presto is 100% open source SQL query engine. A lot of people think about it as SQL for Hadoop, but it's actually even more than SQL for Hadoop. It also has this capability of being able to query other data platforms as well, which makes it pretty unique. So, of course, you can query HDFS. That's a very common use case. But you can also query MySQL, Postgres, Cassandra. I believe there's a connector for Kafka also, and new connectors coming up continuously. And that's one of the benefits of being part of a real open source community project. A few of the things we liked about Presto when we selected it was, first of all, it's a modern code base. So that means it's something that we can actually contribute to and advance very quickly. And that was really important. If we were going to get behind an existing open source solution, we wanted to be one that we could really have an impact on. And Presto's extremely well written, in contrast to perhaps some other SQL solutions that you might see out there. It's also proven at scale. Of course, Presto came from Facebook. They developed it originally, and it is the same version of Presto that you would download, let's say, off of our website, is the exact same version that they run in production. So this is tried and true. This is proven at scale. Martine may share some numbers with you. But nobody is probably running SQL on Hadoop at a larger scale than the Facebook guys, so it's proven. And it's also very fast, which was really a key requirement here. I think the trend today is certainly moving in the direction of interactive performance, and Presto is extremely fast. It is licensed by Apache, meaning it's the same license that you have for Hadoop, so it is free, it is open source. You can contribute to it. We'll talk about that later as well. And prior to this, it wasn't really supported by a major vendor. There are a couple cloud vendors where you can use Presto as a service, but we're really getting behind it to provide sort of comprehensive enterprise support for this project. And you'll also see that although it's most often associated with Facebook, Facebook's not the only one using this technology today. In fact, many of the kind of leading edge internet companies have been deploying Presto at scale for some time. Our goal in all of this is to actually bring that from the technical elite, if you will, the Silicon Valley elite of these internet companies, and make it something that's consumable and usable by a much broader set of enterprises. And that's really what Teradata does. That's kind of what our brand is known for, is bringing the most advanced analytical power to the rest of the enterprise. And that's really what we're trying to do here. So why contribute to SQL on Hadoop? Why would Teradata want to do this? Well, we have this philosophy called the unified data architecture. That effectively means that there's Teradata, there's Aster, there's Hadoop. There are multiple components within your data architecture, and that's not going to go away. There's always going to be multiple components. If any of you work for large enterprises, you know that it's impossible to kind of pick only one database. And so we believe that it's really important to be able to query across these different systems. And we think that Hadoop is also an increasingly important piece of that overall architecture. And so we wanted to make sure that we had a capability that allowed people to query data in place where it exists today. And if that's Hadoop, we now have a world-class way of doing that. We also think that some of the gaps within the SQL on Hadoop space are actually some of the strengths of Teradata. That is to say, things like SQL coverage or performance. Those are two of the dimensions that Teradata has been competing on for 30 plus years. So we think we can add value there, and we think we can really advance the project and help out. And again, why did we choose Presto specifically? I think I talked about most of these items, but I think another one worth mentioning is the fact that Presto is truly distribution agnostic. So you can run it on any of the distros, whatever you choose. In fact, if you're building a SQL application and you're building it on top of Presto, it's now portable. So you could actually move from one distro to another. And we think that's something that customers want because this whole distribution game can be very complicated at times. And it's hard to choose the perfect SQL on Hadoop solution when you don't even know if you've chosen yet the perfect distribution. So Presto allows you to kind of abstract that up a layer and build your application on top of that, and now you can move it. So if you decide down the road, you know what, I'm going to switch from one to the other, that's no problem. So we see that as a value add. So with that, I will turn it over to the father of Presto, the man himself who created Presto at Facebook, along with his team, Martin Traverso.
Thank you, Justin. Hey, everyone. My name is Martin. I'm a software engineer at Facebook. I've been working on Presto for the past 3 years, ever since I joined Facebook, actually. Here we have David, Dane, and Jay, who are also in the Presto team. So I wanted to give you a quick overview of what Presto is, like kind of why we got to where we are, like why did we actually start building it. So when we joined Facebook, the main tool that people used to do analytics at Facebook was Hive. We have hundreds, at that point hundreds, now thousands of people that are actually doing large-scale, complex analytics over our warehouse, several hundred petabytes of data, and all day long. They spend all day long running queries, and Hive wasn't fast enough for that. So we decided we needed a tool that was faster. They could run queries at interactive speeds in the order of seconds to a few minutes. And there were some tools at Facebook that achieved that purpose, but either they weren't powerful enough in terms of features, or they only computed approximate results, etc. They had some drawbacks that weren't. They made them not sufficient for what people need to be able to do. So we basically built Presto as a system optimized for low latency interactive queries. And in a departure from what Hive did years before, we decided to make it support ANSI SQL. So Hive supports a dialect of SQL. And we thought that was we believe that was a good long-term idea, and we still believe that's the case. People at Facebook sometimes complain that, well, we have to learn, we know Hive, HiveQL, we have to learn SQL, but supporting the actual SQL makes it easier to interoperate with other tools. I think it really is one of the reasons why Teradata decided to go after Presto. In the long term, I think that's a pretty good strategy. One of the big features about Presto, this is something that we didn't set out to do in the beginning, but it kind of evolved over time, and then we could quickly realize it was something that we need to do, and ended up benefiting us in many ways, is to make the system extensible. And we're going to talk about how Presto can be extended in a little bit. So just a brief timeline. So we started developing Presto. It was a team of 4 people in August 2012. We rolled out to production the first version in December, so only a few months after. We started Presto with the goal of making it open source eventually. So all development happened on GitHub. We used pull requests, like normal, all the process you would do for an open source project, except that was a close in a private repo. And then in November 2013, we opened it up to everyone. We made it open source. Since then, we've had dozens of releases. We have 65 contributors. Some of them are regular contributors. We got the people at Netflix. They are contributing very frequently. I know some of you may have seen the previous talk from Netflix. And now we're very happy that Teradata is joining the community. We believe it's going to provide as a way to accelerate our development and focus on features and areas of Presto that we just don't have the bandwidth or the time to do during our work at Facebook. So today, these numbers are a couple months old, but we are basically running several clusters, like about 10 or so clusters, and we have thousands of people querying Presto every single day, every month. About 1,000 people a day, but over a month it adds up to 4,000 people or so. And this is mostly for the warehouse. We have Presto running on for other purposes, and I'll mention how we achieve that in a bit. So those people run millions of queries, scanning several petabytes of data. It's a pretty impressive scale. So at a high level, just to give you an idea of how Presto works, there's not much magic. Presto is a pretty traditional parallel distributed SQL engine. There's a coordinator. Every cluster has one coordinator that is basically responsible for taking the SQL statement from the client, parsing it, analyzing it, planning, optimizing it, and then setting up the execution pipeline across all the workers in the cluster. Basically, it establishes all the connections between the workers, and then the workers start processing. So basically, each worker pulls data from a source, and the source can be some external system, or it can be another worker upstream in the pipeline. And when they process data, they take a chunk, they apply filters, projections, aggregations, whatever the query is set up to do, and then they stick the data in an output buffer in memory for the next worker in the pipeline to come and fetch it. And then at some point, the client comes and retrieves the results from the last stage of the query. So in order to be able to run a query, or plan and execute a query, Presto needs a few pieces of information from a data source. It first needs metadata about tables. Like, it needs to know the names of the tables, the fields they have, the types of each of the fields. It also needs to be able to know where the chunks of that table live or can be accessed from. In the case of Hive, of data that lives in Hive, this translates to knowing where the files are on HDFS, and splitting them up into chunks. And then in order to actually run the process, do the processing over the data, it needs a way to fetch that data from the external data source. So there are basically 3 APIs. There's a metadata API, a data location API, and a streaming API. And we decided to create an abstraction over those APIs and make it extensible through a plugin mechanism. So the idea is that a plugin can provide an implementation of each of these 3 APIs, and as long as as data is exposed in a tabular form, and using types that Presto understands, Presto can run queries over that data. Now, the powerful thing is that you can have multiple plugins deployed in a single installation, and you can fetch data from one source, join against data from a different source, without having to copy all the data from from some source, put into Hive before you can do your analytics. So it allows you to do analytics in place where the data lives without having to pull it out. So today we have a bunch of connectors. We support all the major Hadoop distributions. We have, this is a contribution from external developer, a connector for Cassandra. Groupon contributed the Kafka plugin. They also contribute a couple other plugins that we're reviewing. We're hopefully going to merge them in soon. And we also support querying from MySQL, Postgres, and we have a simple framework for creating connectors for any data source that exposes, that has a JDBC connector. So it's very, very powerful. It's very easy to create connectors. In fact, Teradata, over the past couple of weeks, they create a connector that can be used for testing and make it easy to see the performance of certain queries of the engine and so on. So connectors are not the only extension point for Presto. It is also possible to define plugins or create plugins that add new types and new functions and operators for those types. In fact, for example, we have one of the plugins that comes with the Presto package is a plugin for machine learning functions. There's a function that trains an SVM model. They introduce a new type, an SVM model type, and functions that can train an SVM model and do classification and then evaluate the model over data. And this all packaged inside a single plugin that can be added to a server, and it makes the functions available to Presto to use. So speed, query performance is generally dominated by, first of all, by how well can the engine prune the data set before it even starts running a query or loading the data. It also depends, it's also dominated by how fast the data can be retrieved from external systems. For example, getting data from Hive and HDFS for a query that filters by partition key can be pretty decent if Presto can prune the data set to a specific partition. That is not if you can avoid scanning the entire data for a single table. Some data sources may be more efficient at providing data. For example, if you have a data source that is backed by Flash or is in memory, et cetera, they can be a lot faster. So that plays a big role in how fast Presto can run a query. But if we take that out of the picture and look at the engine itself, it's actually still pretty fast. And there's a couple tricks that we implemented in order to pull this off. So one of the things is that this is actually one of the things that we realized very early on. We had tables in Hive that had hundreds of thousands of partitions, lots of files on HDFS, and the strategy of trying to enumerate all the partitions, enumerate all the files before the query starts executing doesn't actually work very well for interactive queries, because you may have a query that just does someone wants to get a sample of 10 rows from a table. If you run a select start from table limit 10, that query will be dominated by the cost of enumerating all the partitions, enumerating all the files, when the query itself may take only 100 milliseconds. So what we do in Presto is we pipeline the execution, the scheduling and the execution end to end. So as soon as the engine starts enumerating partitions, it very quickly starts enumerating files and scheduling the work. And the query may be done before all the partitions and all the files have been traversed by the scheduler and execution engine. Then, so Presto is built using Java, and Java is a pretty impressive, the JVM is a pretty impressive piece of technology. And it's one of the things that helps a lot in making Presto really fast. So from that point of view, it's just a matter of getting out of the way of what the VM does and like making it easy for the VM to take the code for a query, optimize it, and turn it into machine code very efficiently. And that basically takes things like being very careful about how the loops are structured, trying not to allocate memory in the inner loop, etc. Using memory representations that are efficient to access without having to chase tons of pointers around, etc. And one of the things we do is we generate bytecode for queries. So effectively, we're taking a SQL query, compiling it to bytecode, and then letting the VM execute it. So that actually makes things very fast. We're always working on performance improvements. I mean, we are not done yet in terms of where we can generate code and all the performance and CPU optimization we can do, but it's pretty good at this point. Last year, we wrote a new reader for org, the org file format, and we basically implemented support for, there's three things that it supports. One is reading data in vectorized form, so you can read columns at a time instead of scanning the files row at a time. And this plays better with the way the Presto engine operates. It thinks about data in terms of pages of data, columns, and so on. So by reducing or getting rid of that impedance mismatch, we save some time, some CPU. It can also do lazy reads. So the engine doesn't need to decode and decompress and decode columns until they're actually needed. For example, if you have a very selective filter, but you are selecting a bunch of columns from a table, you don't need to even decode those other columns until the filter matches. That can be a massive speed up for selective queries. And then, remind me again of the push down. So the other thing, I mentioned that performance can be dominated by how well you can prune the data sets before you have to decode them, or load them, decode them, etc. And the connector API allows you to allows Presto to push down predicates into the connectors. The org reader that we wrote can actually take advantage of those predicates and push them all the way into the code that scans the data from the files. So you can look at some of the statistics that are kept in the file and skip entire chunks of data from those files. So this is a massive speed up if the filters are selective and the files contain the necessary information. So over the past few months, we've been working on stability, performance. It's something that it's a never-ending thing. We always focus on performance. We always focus on making things as efficient as possible. I mean, growth at Facebook is, usage at Facebook is growing significantly, but we don't want to have to run 10 times more machines in order to satisfy the workload. So we are always looking for improvement, CPU utilization improvements, et cetera. So we are, over the next few, well, we've done some work on the planner and execution engine to make some of those improvements. We're going to be focusing on those like in the short term, and we expect that to be an ongoing effort. We recently added some features to the language, like support for insert, delete. We're going to be focusing more on additional features, like correlated subqueries, scalar subqueries, updates, et cetera, and then bringing support for insert, delete, and all those other statements to connectors. I mean, we have support for them in the engine. We need to apply the other functionality to the connectors so they can be used. And so one of the things that I mentioned, we're always working on performance. One of the efforts we are undergoing right now is implementing a new column store that basically organizes the data in the way Presto needs it to be able to operate efficiently. And we have the code is on GitHub, is part of the code base. We are about to roll this out to internal customers at Facebook. And we still don't recommend that people use it because it's experimental, still evolving significantly, but we expect it to be production ready very soon. And then finally, security is a big thing. Inside Facebook, there's a big push for this. This is one of the questions that we get from everyone that is thinking about Presto, like what is the security story and all that. So we're starting to work on that, adding authentication, authorization. We're going to be modifying the connector API so that connectors can participate in the authentication and validation and so on. All right, so, well, Justin already mentioned before that Presto is licensed under Apache, the Apache license. We do all development in the open on GitHub. You can actually go download the repo. You can see all the history of the code all the way to the first commit if you want. We try to release every 1 to 2 weeks. Over the past couple of months, we've done one release a week, and we're trying to keep that pace. So we fix issues, we improve things all the time. So and if you guys are following the project, you try to keep up with the release as they come out. Teradata, well, you're going to talk about that, right? Yeah. And so if you guys want to join the community, we welcome anyone that wants to contribute to the code base.
Cool. Right. So on that point about, on that point about releases every 1 or 2 weeks, that's a pretty frenetic pace. So what we actually do from a release standpoint is we pick builds that are stable and run a whole bunch of extra tests on that. And certify specific releases, because it would be very difficult for us to support every week's new release. And also you as customers probably wouldn't want to have to worry about which version you have all the time. So we pick selectively, and those are the ones that will be available on teradata.com/Presto. All of the contributions that we make are 100% open source, and they do end up back into the Presto code base almost immediately after that release. But you can always find a stable and supportable release on our site. Let me talk a little bit about the contributions specifically that Teradata is going to make here and what that roadmap looks like. So phase 1, which is actually already available today, was available as of Monday, is really designed to help more people experience Presto. And that includes an installer that we built, very simple to use installer. I've used it myself. I'm not nearly as smart as Martin, and I've done it many times. It takes a few minutes. So that makes it a lot easier for people to play with. In fact, on our website, you'll also find Presto as part of a VM, both a Hortonworks VM and a Cloudera VM. So if you don't even want to go through the trouble of installing it on a cluster, you can just download this VM and play with it right away. We've also added a bunch of documentation, again, to make it easier to understand how to use Presto, including a quick start guide. And we've added some command line driven management and monitoring tools so that you can manage your cluster if you do decide to put it into production. Phase 2, which is coming up very quickly towards the end of this year, is all about integrating Presto a little bit more with the rest of the Hadoop ecosystem. And so we're going to do that with Yarn integration so that you'll have better resource management. So if you are subscribing to the philosophy of a data lake and you are using that data lake for multiple purposes, Yarn is probably an important ingredient for you. So by the end of this year, we will have Yarn integration. And we'll also integrate with existing Hadoop cluster management tools. So that includes Embari and most likely Cloudera Manager as well by the end of this year. Phase 3 is then about taking it to the next level to really make it a tool that you can connect your BI tools to and really use it for reporting and ad hoc analyses seamlessly. And so that includes a ODBC driver, which we think is really important here. And we've heard that from a lot of the early adopters of Presto. That they've all told us, if we can have a functional ODBC driver, that's really important. Adding more security, Martin touched on some of that as well. We're going to help out in that arena. Certainly, we've done that a lot in our existing database systems. And hopefully throughout, continuing to expand that SQL coverage as well. It is ANSI SQL, which was one of the reasons we went with Presto, as Martin mentioned. There are still a few gaps in the SQL coverage, and we hope that we can fill those in as well along the way. And then throughout, we're offering this commercial support so that you know that if you are deploying Presto in production, you have a company like Teradata that's been doing this a long time to support you and help you with that production. We also, as a slight aside, we have a consulting arm called Think Big Analytics that some of you may have heard of. They were acquired roughly around the same time as Hadapt. and they also provide services to help you get it up and running, and have developed quite a bit of expertise over the last few months in the area of Presto as well. Just to give you a sense of just how large our commitment is to Presto, this is not sort of a little hobby side exercise that we're doing here. We're really getting behind Presto with full force. We have 16 contributors that are have all joined Presto already, and all 16 of these come from the former Hadoop team, which is now the Center for Hadoop. And so you'll see very experienced people there, both in terms of the SQL and Hadoop side of things, but also real database systems. And I'll just point out a couple real quick. Kamil Bajda-Pawlikowski, who I mentioned is my co-founder from Hadoop. He's our chief architect on this project. And then Matt Fuller was actually the guy who worked on the optimizer at Vertica and ran the Vertica optimizer team. And he runs our Presto team. So, a real group of veteran contributors here, and we're hoping to really accelerate Presto's roadmap. Early feedback so far has been extremely positive. So we talked to some of the early users of Presto. We wanted to take their temperature and say, hey, what do you guys think about this idea? And they were super enthusiastic about it. We've got a couple quotes here, but this only begins to scratch the surface of the enthusiasm that we've felt so far today. And these are the websites. So on Teradata.com/Presto, you can find that stable release if you'd like that, or you can go directly to GitHub and see the source code there. PrestoDB.io is also a website specifically about the Presto project. So with that, I do want to take some questions. I'll also mention that the gentleman in the blue shirts here will be at the Teradata booth afterwards. So if you have additional questions, you've got both Facebook and Teradata folks from the Center for Hadoop who will be at the booth answering questions. But let me take a few here while we still have some time. If you don't mind walking to the microphone, that would be awesome.
Hi there.
Hi.
Any plans to change the governance structure of Presto now there are more contributors, like moving to Apache? Not
Yeah,
Apache
great question.
license, but Apache Foundation.
Great question. I'll answer that and feel free to jump in. That is an important distinction. It is Apache license, the same license, but it doesn't use Apache Software Foundation governance. We think in the near term that's actually an advantage, perhaps, because we can move very quickly, working very closely with the Facebook team to advance the project very quickly. But certainly as the project matures, or the community, I should say, matures, and you get more and more contributors, then I think that's where an ASF model is often beneficial. Anything you would add to that?
No.
Okay.
Summarize as well.
Yeah.
Can you talk about fault tolerance? Queries run, they fail midway, what happens? Are they retried? To try again?
Yeah, so today, there's some fault tolerance for some operations. Because for example, when Presto is fetching data from HDFS, if there's an issue with a data node, et cetera, it will retry like a few times, and then eventually it will say, if it keeps failing, it will say, well, I can't, and it will fail the query. In terms of the query engine, it's Presto itself, and inside the query engine, a query starts executing, gets assigned to a bunch of nodes. If any one of the nodes dies, that is right, any queries that are assigned to run on that node will fail. There's no checkpointing or recovery at this point. This is something that we want to work on over time. We just haven't had the immediate need or need to focus on that. So.
By the way, I'll just add one point there, which is, I think this is a reason why we feel, at least, that Hive is actually quite complementary to what we're doing. Some people have asked, well, how does Presto compare to all these other SQL tools? We think in the case of Hive, you get a lot of that query fault tolerance, particularly when it's going through the MapReduce framework, you get that query fault tolerance. So Hive is really good for kind of long-running batch-oriented queries, and we think certainly people will continue to use Hive for those types of workloads. But if you're looking for those really short-running, interactive, high-performance queries, that's where we think a different tool makes sense, and that's where we think Presto makes sense. I think there was another question. Yeah.
This is more a question for Teradata. How does this work with Query Grid?
Yeah, great question. And you know what? I probably should have put that in my slide deck. Marketing will probably be mad at me. So Query Grid, of course, is the way that Teradata connects to different aspects of the UDA that I mentioned up front. So for example, if you want to query from the Teradata data warehousing appliance to Hadoop, you can use this tool called Query Grid. Presto will absolutely feature very prominently in that because Presto will become the Hadoop connector to QueryGrid. So in other words, if you want to now submit those queries to Hadoop through QueryGrid, they'll go through Presto and push more of that work down to the Hadoop cluster at higher performance. So the net result, to answer your question very simply, is you'll get better performance now out of QueryGrid than you did before where it was going through Hive. That's the way it's built today. Yeah.
Basically, I have two questions. The first questions are about the integration with Yarn and allowing to run the Presto in Yarn containers. And the second question is, are you planning to make a Presto as execution engine with ability, let's say, as run as a Hive shell?
Do you want to answer the second question?
So can you repeat the second question?
Yarn,
Yeah.
execution engine for Hive. First, second questions.
I haven't thought about the second one.
Okay. For instance, let's take a look on Tez, which can be used as execution engine
Right.
behind Hive. I'm typing Hive, and then set execution engine equal Tez, and started running a query, which transparently convert from MapReduce to Tez. The same, there are Hive tickets to do the same with Spark. My question, what's your opinion and what's your roadmap on Presto?
Yeah, so it's not something we thought about or not something we are designing for. I think there will be a bunch of challenges there. Like, for example, Presto is not designed. So with Hive, with HiveQL, you can actually plug in custom mappers, custom logic that is executed by, external scripts. So you can invoke a bash script in the middle of your Hive query. This is not something that we envision Presto doing. And for example, in particular, at Facebook and most of the way most people use Presto is in shared environments where you have hundreds of people or thousands of people actually using the same system at the same time. So once you start going down that path, you lose the ability to control resources very well, to isolate workloads, et cetera. And one user may affect the experience of other users. So I'm not sure that's a path we want to go into. There's other challenges that we would need to overcome for that.
Okay, and the second question was Yarn.
Yes, and what was the question about Yarn? I mean, that's...
Are you going to marry Presto and Yarn? Not to run Presto, not as standalone workers on every node, but run Presto as a part of Yarn framework. It means you are starting application master. Application master start Presto containers, Presto executors as Yarn containers, exactly as right now, MapReduce, Tez, and Spark.
Yeah, I mean, tell me if I'm wrong over here, guys, but I think that's exactly what we're doing for the end of this year.
Okay.
Yep.
Thank you.
In Hadoop ecosystem, there is already column storage format like ORC or Parquet. So why would you add a new native storage format for Presto?
Okay. Can you repeat the last part of the question?
Why Presto add a new native column storage?
Oh, well, we're adding a new columnar store. So one of the things we found is that the APIs that HDFS and the APIs that the Hive readers provide are not a very good fit for the way Presto needs to operate. So first of all, it opens up the ability to have custom APIs that are designed for the way Presto thinks, and then it allows us to do like other things, like, for example, store the data in tier storage. Like we can put data in Flash, we can put some data on spinning disk, we can keep some data in memory. So it gives us more flexibility in terms of how we where we place the data, how we shuffle it, how we manage it, to make the engine play better with the way data is structured and organized and replicated across the system.
We may have time for one more question if there's one more. Nope. Okay, all right, thank you guys. Like I said, we'll be at the booth if you have more questions.